I'm Kacper. In this video we are going to continue from the project from the previous Draive framework introduction video. This time we are going to build a simple graphical interface based chat. As previously, you can set up the project on your own using those commands, and it will create the virtual environment and provide the dependencies from the PyProject DOM. So where we have finished before, we had the simple application with the main, which was creating a Draive context, defining the OpenAI client, OpenAI chat config, and the implementation for our generate text function, which generated the completion for simple hello. So now we are going to use a Chainlit, which is the library for creating simple chat solutions. There is a function decorator called onMessage, which we are going to use to handle incoming messages. It has to be async and we have to respond for the message. It will return nothing and it will take a message, a type message from the Chainlit. So now we can get the message and access its content, which is a string. So now if we launch this application as the Chainlit application, we'll register on message handler, and for each incoming message from the chat, we'll get the message and can access its content. So as we previously were generating text, we can easily move that part to our message handler. So for each message, we create a new context, define the OpenAI stuff, and instead of hard coding hello, we can use the message content to get the content of message for generating text. To respond, we have to prepare our own message and send it. So let's prepare a response, which will be a message of author assistant and the content of our result. And now we can remove the previous main function as it is no longer needed. Instead of printing, we are going to send this message. So now we have implemented a chat solution based on Chainlit, which responds to the message we passed to it. So let's see how it looks like. To launch this, we have to use the Chainlit command line interface, which is Chainlit run, and pass this file. It was previously our main, so we have to pass this file there. So it is a sources, chat, and main. So now we should be able to see our chat. Yes. So there's a chat window which was generated by Chainlit, and now if we say hello, we'll get the response from our ChatGPT request generated by generate text. So we said hello, we got the response after some time. So now if we ask it what is the weather, it will say that it has no access to the weather information. But if we ask it to repeat that, you will notice that it has no idea about the context. So the model was instructed only with the incoming message, not with the whole thread. So let's fix that now. How to do this? We have to use another helper from the Draive, which is optimized for generating conversations instead of simple text. So instead of using generate text, we'll have to import conversation completion, which is the helper function for generating completions of the conversations. So now the output is different because conversation completion uses conversation message, which contains some metadata about the messages. And here, instead of passing result, we have to access its content and display it as a string. So now we are using another Draive helper function, which is suitable for handling conversations instead of just handling the texts. But where is our memory? There is another argument which is called memory, but this handler is called for each message. It does not have the context of the user session. So we have to implement one more thing from Chainlit, which is on chat start, which is the handler called on starting a new chat to set up the session. So let's call it a setup. And here we have a chance to set up a new conversation chat. So we'll have to use the user session, which allows us to store user session specific data, and we can set there our memory. But what is our memory? We can use many different implementations of memory, but for this example we'll use a simple solution from Draive, which is called volatile accumulative memory. It is in-memory memory solution, so it is wiped out when the application finishes. We will have to store the conversation messages, as those memories are allowed to store many different types. And now we have the session with the message here. So one note here, few of those Chainlit items does not have full typing, so we're going to ignore those. And now we have to access this memory in our conversation response. So we are going to get the memory from the user session. And as previously, we have to ignore type for a minute here, as we are launching this in strict type checking. Okay, so now we are using the setup from Chainlit to set up user session, which will initialize our memory solution, which is just simple accumulative memory, adding up the messages, and pass it to the conversation completion. Conversation completion handler handles all stuff regarding the memory usage. So it fetches the messages to use for the conversation, and it also automatically saves them, so we don't have to do anything else. So let's check it out. Okay, so what is the weather now? Could you repeat? And as you can see here, we are now handling the conversation history through the memory, and the model is knowing what was the previous message, so can answer our request for repeating the last message. Great. So now we have a fully functional chat with our model, but let's make one more additional feature. Let's go back to the code. So right now we are talking with chat within chat with GPT 3.5 model. It is fine, we can use it a lot, but it is not that useful yet. So how about allowing this chat to use some kind of a tool? There is a dedicated solution for that as well from Draive. It is called a tool. it is yet another decorator we're going to use to define a function. Let's have a tool for accessing websites, which will get the URL, and result will be a string. For now, we can just return the URL. So let me explain it. Tool annotation converts this function to be a tool representable to the OpenAI services and any other service provider which is capable of calling and handling functions. So now we have defined the function. We can use it within our conversation as tools available to the model. So now we can ask for website's content in addition to just chatting with the model. So let me quickly paste implementation of simple function fetching the result using async client from HTTPX and the response. To read the contents of this message or the response, we are going to use a beautiful soup. So we are getting the client, which follows redirects, gets our response for the URL we have provided, gets the content and parses it as the HTML. Then finds the main or body of the page and returns its text. It is really simple, lacks of handling of errors like invalid responses, etc. But it is good for simple presentation how this tool could be used and utilized by the model. So as we defined our function, we're returning the result. Now we have also provided it to the conversation completion. We can try it out. So when we get it here again to the chat, we can say, hi, what is the HTTPS mickwidow.com website about? And now the model, instead of accessing its own knowledge, will be able to access any website we provide or it requires to be provided. So here is our response. We can go back to the code, and in the logs, which we have enabled from the previous recording, we can see that indeed we were using a function. So the OpenAI calls use the our input and the content of the question. Then we have requested the mickwidow.com website content, and here's our content. Finally, the model responded, and we have the final result. Those logs are truncated here to be more clean to quickly look up. So that's it for today's video. We have learned how to use the tools. We have learned how to utilize another helper function, which is called conversation completion and is optimized for handling conversations. We are also building a simple chat solution based on Chainlit to have a UI for that. In the next videos, we are going to dive deeper into more details about accessing the context states and perhaps using more of the AI inside the tools, but that's for the future.